Everyone, in this video we're going to go through the term 1 holiday homework questions, so the 70 multiple choice questions. So in this one we'll just go through questions 11 to 20 just to keep it relatively short or shorter, but we'll see how we go. So the previous one I think went for over 30 minutes, not ideal to go over that 30-minute mark, but we'll see how we go. Anyway, all right, so these questions seem to focus on simultaneous equations. So the methods you can see are quite similar with the questions, and I'll just explain, where the calculator can be used. All right, so let's start with question 11. So given the two linear simultaneous equations, so we've got those two equations there, and you could go on to solve it, but it's just telling us what is going on when m is either equal to 3 or any number other than 3. So, I thought, well, if we plug that into the calculator, it's probably going to be a lot easier than finding the solution. So you can solve for m, which we'll do in the later questions, but given that it's a multiple choice question, it's either going to be 3 or not 3. So let's see what happens when we put m equals 3 into our calculator. Just get the calculator up. Oh, I don't have the calculator there. Let me just flip my computer and get the calculator up. I don't know what happened. All these tabs changing and stuff, I don't know. All right, ClassPad. You think I'd press pause, taking a while. There we go. All right, so I don't know whether I did this on this calculator or the previous one, the physical one. All right, so if we're substituting a value in for a pronumeral, all we need to do is write the expression and then say, all right, let's let m equal 3. Or you can, actually I think this one's probably easier to do without the calculator. Not too hard now that I look at it. You can put it in the calculator, but probably a lot quicker to not use the calculator. So bye-bye calculator. All right, so the first term we've got mx. So if m is 3, it's going to be 3x. We've got minus m plus 1. So 3 plus 1 is 4. So minus 4y is equal to 3 plus 2, which is 5. All right, so there's your first equation when we let m equal 3. Then for our second equation, all right, do the same thing. We get 6x minus 8y equals 9. Now, because we've got the two equations and we don't need to rearrange them in the form y equals mx plus c, because I can see that the coefficients are clearly in the same ratios. All right, so 3 over 6 is the same as negative 4 over negative 8, gives you a half. So that means that the two lines are going to have the same gradient. All right, so that's what testing the ratio of the coefficients does. All right, I'll put that negative in there as well. Now, it tells me that they've got the same gradient. So they're either going to be parallel lines or they're going to be the same line. So if they were the same line, these would also be in the same ratio. So that 9 would be 10. All right, but it's not, it's 9. So because they're different, they're parallel lines. They're not the same line. So if you've got parallel lines, all right, you've got no solution. Okay, so they don't cross. If they cross, you have what's called a unique solution. Or if you have the same line, so if that was one line, and let's say that was 10, which would then make it the same line. So it's on top of it. All right, but it's not for this question. Okay, so it's no solution. So you could go on and solve for m, but just given the multiple choice options, we can just test m equals 3 straight away. Now you can do that for other questions as well. And during reading time, you might start considering whether it's actually going to be quicker to do that. And you can see I went to use my calculator, didn't even need it. It was the question was like a 1-minute question. Looks quite complicated, not complicated at all. All right, question 12. Given the two linear simultaneous equations, blah, 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 and blah, 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 then we've got all these situations. So you could substitute in values of n and values of m but we've got different combinations. So it would take a little bit more time. Here it was either 3 or not 3, so it was quite easy to test. Here we've got n equals -2 or 2, and then m could be -1 or 1. I guess if you got stuck, you could substitute it in like we did the previous one. It would probably just take you a little bit longer. All right, so what I did is there's 2 ways that you can test, or there's probably more than 2 ways, but 2 main ways that you can test the type of solutions. You'll notice what I've done is I've rearranged them in the form, let me just get a different color, y equals mx plus c. All right, so straight away we can see that's our gradient and our y-intercept. So if your gradients are the same, just like before, it's either going to be parallel or the same line. And then, you know, if your y-intercept's the same, clearly the same line. Then, so I did that for both equations. So here's equation number 1 and here's equation number 2. And I just tested it. So I took my gradients. So here's my gradients here. And you can see I just tested it for different values of n and m. And then I tested the, oh my gosh, can't talk properly, our y-intercept. Okay, so similar to probably substituting them there, but I do think it's a little bit quicker to do it this way as opposed to substituting there. So, yeah, we get n equals 2 and m equals 1. All right, moving along. Question 13, if x plus a is a factor of blah, 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 where a is an element of any real value excluding 0, then the value of a is. All right, so basically just using the factor theorem here. So if x plus a is a factor, that means when we substitute in -a, your function is equal to 0. So I'm just thinking whether I just plug this straight into my calculator using define. Let's have a quick look. All right, so yeah, I'm gonna just have to flip my computer over, which is very annoying. All right, define f of x. 8x cubed minus 14x. Now, it's probably a bit tedious. I know you're probably watching me not plugging it into your calculator at the same time, but it might be a good idea just to get used to doing that. All right, so I've defined it. I'm kind of a bit unsure about this term here, so I'm going to put a times in between because sometimes it doesn't like different pronumerals. All right, so we're going to solve for f of -a is equal to 0, and we're solving for a. All right, so we get -2 and 0. It told us in the question it can't equal 0, so obviously then it's a -2. The reason it probably can't equal 0, so it's any real value excluding 0, because if we substitute 0 into here, we're going to get rid of that x term. So that's probably why we can't equal 0. Or not giving 0 as an option. All right, question 14. The simultaneous linear equations, blah, 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 have infinitely many solutions. So again, you can test, you can just substitute these into your equations. You don't have to go through, but I love solving simultaneous equations, and I know that makes me sound very nerdy, but it's just a great process. Like, you've just got your and just make sure it's in the right order. So we've got our coefficients of y and our coefficients of x. X doesn't have to be first. You often see it x being first, but you're just doing your coefficients of y. And I've done my x's first, but you've got 2 over m, so you can see that's here. And then our coefficients of x, all right, m minus 1. And you could just solve that on your calculator. You can see I've gone through and done the working out, but it's a multiple choice question. You can just solve that quickly on your calculator. I also just realized you can get, yeah, probably other things you can do on your calculator. These questions do turn up on exam 1, so it's probably a good idea to not focus too much on the calculator for these. All right, so we get m equals 3 and m equals negative 2. So remember, all that is telling us is that when m equals 3 and m equals negative 2, you have the same gradient. All right, so you've got the same gradient, so you've got two scenarios there. You've got either parallel lines, so no solutions, or you've got the same line, and that's when you got infinitely many solutions. So to be the same line, your ratio of your constants also has to be the same. So you can see I've done that test here. So 2 over k has to equal 2 over m. So that means that k has to equal m. So that means we've got, what did I do? I'm like, why couldn't we have 3? So we didn't have the option of m equals 3 and k equals 3. We only have the option here where they're the same. Okay, so they have to be the same. Alrighty, moving along. They could have both been 3 as well, but that wasn't an option. Okay, question 15. A set of 3 numbers that could be solutions of, did that just glitch? Blah, blah, blah. All right, let me just have a look. How did I do this? Okay. I think this one, it took me a while to figure out how to do. So I might have to pause and figure out what I did on the calculator. All right, so I must have defined it, let it equal 0, and got a. Test all values of x to get same value of a. All right, I think I can do that quite confidently without, because I did these questions a while ago, these solutions. So I'm trying to figure out, trying to remember what I did. All right, x cubed plus a times x. And I remember when I did this question, I thought, write yourself a little note so you remember what you actually did, because I think this one took me a little while. We don't let it equal 0, we're just defining the function. All right, so we've got Dunskies. All right, we're going to solve, and we're solving for a. All right, so we're going to let it equal 0 because it does equal 0, and we're solving for a. All right, so we get that expression for a. Now, there's probably other ways you can do this. This, to me, when I was thinking how to do it, seemed the most straightforward, but obviously with maths, there's often more than one way to solve it. So there probably is another way of doing this. All right, so all I did was I took this part and I said, we're just going to have to test. All right, so we've got a set of 3 numbers, could be solutions. So that means that when I solve this, I need to get the same value of a. I can't have a different value of a. A has to be the same value. All right, so I just put my expression in and then do, so without the a equals, given that x is equal to, and then I just substituted in different values. Now, I don't know, you can see what double up. So we've got 2 options with -2, but you've got to really test all 3 numbers. So if we start with a, we can do x equals 3, we get that number there. All right, let's test number 4, and we don't get the same number. So we move on. Option B, -4, and let's test that with -3, not the same number, move along. So remember, we want the same answer if it's going to be giving us a solution. So we've got -2, so I'm doing option C now, -1, all right, not the same number. Then option D, -2, 6, so we've got -11 there. Whoops, not -6. I was like, oh, I didn't get the right answer. All right, it's just 6. There we go, -11. And then 7, we also get -11. So option D. I wouldn't be surprised if there was another way of doing that, but I quite like the way I worked it out. All right, remember, it's maths methods, so you can, multiple methods. Question 16. So many words. This is, I look at this and I just think this would put so many students off. This is why it's important during reading time to read something like this and be like, okay, there's a lot of information there, but it's actually not as bad as it seems, because ultimately you're just solving linear equations. All right, so several students were investigating the system of linear simultaneous equations. So we've got them here, blah, blah. And then you've got Alan, Ben, Colin, and David, so A, B, C, and D, who all think different things. Okay, so we've got to see who is right. So don't worry too much about Alan, Ben, Colin, and David, and Edward. Sorry, Edward, didn't even notice you there. Because we'll just go straight ahead and solve. All right, we're just going to go straight ahead and solve these linear simultaneous equations, or the type of solutions, I should say. All right, so we do the ratio of the coefficients, and we get the same gradient when k equals -5 and k equals 3. So that means we can't, there's a unique solution. Oh, I don't want to use that one. So a unique solution all right, when you've got any real value excluding those two. Okay, so k equals -5 and k equals 3, it's either going to be parallel lines or same line. And for anything other than -5 and 3, we're going to have a unique solution. All right, so Alan stated there is no solution when k equals 3 and infinite. Why didn't I circle Alan? Maybe I went on. Okay, I think I went on. Because you could have circled Alan at that point, but I obviously went on. So when k equals 3, we've got the same line. All right, so infinite solutions. So when k equals 3, we have infinite solutions, whereas Alan said we have no solution. So sorry, Alan, you are wrong. Ba-bom. All right, so for Ben, he said there was infinite solutions when k equals 3. So Ben, you get a circle. Colin also said something good, which was there's a unique solution when k is an element of R, excluding blah, 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 like we did before. David stated there was a unique solution when k equaled that or that. Bom, bom. Sorry, David, I feel like crossing them out now. And then Edward said there was no solution when k equals -3. There was no -3 situation there happening, Edward. So Ben and Colin are correct. That is why option B is your answer. All right. And just going back to this, you can put all this into your calculator, all right, to solve. No, I think I probably did because there's not much working out there. All right, question 17. Let f and g be functions such that, these questions turn up all the time on past exams, and I think this is actually a past exam question. If it's not coloured, it's usually a past exam question. And students kind of get off-put because they're not used to seeing this. We have a composite function here. So it's saying f of g of 3. Now, you're like, oh gosh, I don't know, but g of 3, it tells me is equal to 2. All right, g of 3 is equal to 2. So f of g of 3, instead of having g of 3 in there, we can just substitute it with the 2, and f of 2 is equal to 5. That's the sort of question you can do during reading time, and you're thinking about it in your head, and it would take you 20 seconds to do. Easy question, but just looks complicated. All right, question 18. We're breezing through this one, guys. All right, we've got this equation, has no real roots for. All right, so we're just going to use the discriminant. All right, so we've got b squared minus 4ac. We're substituting everything in. I'm just trying to think if you could put that into your calculator. You probably could solve at this point. Yeah, but I've put all the working outs there, so if it was a tech-free question, you can see. The reason why our inequality sign changes direction, and you can solve using your inequality sign on your calculator, is because of this -4. So when you're multiplying or dividing by a -4, your inequality sign changes direction. So let's just see what does happen. -4p squared plus 24p minus 4. And then our inequality signs are here. So less than 0, and we're solving for p. Oh gosh, what is it doing to me? No, I didn't want that actually. Yeah, I was thinking, why did I do that by hand? It's because it's giving you all these values for p, and I don't think it's going to make any difference. It's not going to give it to you as an expression. It's gone on to solve for p, which is probably why, yeah, so it's gone on to solve it, which is not what we wanted. We just wanted to do that expression. I wonder if I put that down, if it's going to simplify for me. Sorry guys. Where's my thing? I don't want to expand. Don't want to factorize. I don't know. Simplify? No. I don't know. Probably simplify it if I did know. All right. Just do it by hand. Okay, so you can see what our options are. If you got to the point here where it's highlighted in yellow, you can see that clearly it's been factorized. So taking that -4 out as a common factor. But I think for this type of question, it would be the inequality sign that would get people. So we're dividing both sides by -4 to get rid of it. So the inequality sign does change direction. All right, question 19. The simultaneous linear equations we've done so many of them. All right, a unique solution only for, so this is the first time we've done a unique solution though. So when we solve for our ratios, we get m squared does not equal 49, or you can solve for m, but we ultimately want m to be, we want to know what m can't be. So it can be any real value excluding the square root of 49, and we've got to include both a positive and -7. All right, easy question, that one. And then we'll stop at 20. The simultaneous linear equations, blah, 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 have no solution. All right, we've done so many of these, and this is not a hard one. It does have k in there, but just remember, this is your coefficient of x is put in brackets for you. So here we've got 2, so it's 2 over k plus 1. And don't forget your negatives as well. Solving for k, you can solve on your calculator. So it's no solution, so we want parallel lines. So we don't want these to be equal. All right, so can't equal 3. Sorry, I think what I've done there, let me just fix that up, because I solved that on my calculator. So k, I don't think I'd use it, can't equal. So k cannot equal -4. And you can just do a test. So if we substitute in 3, we would have 5 over 10, which is a half, and then would have a half again. So if k was equal to 3, it would be infinite solutions, but if it was -4, it would be no solutions. All right, we're going to finish there. 10 questions per video. Yeah, bye guys.